Welcome to Think 2021 and the session entitled Integration Trends in Modern Application Development. Under this theme, we are going to be specifically talking about modern integration trends using Agile integration. So what is Agile integration? Well, let's talk about it from the practices around people and process, architecture and technology. IBM has spent significant time gathering the emerging best practices in these areas and codifying them in a way that organizations can replicate. We call it Agile integration, and we think it's the best approach to successfully modernizing your efforts in integration. Let's look at the themes which are affecting integration, coming from the application development space, which is changing rapidly to enable a more nimble and exploratory approach to application development. First, there's people and process. Decentralized ownership helps accelerate agility and innovation, allowing individual team members to contribute in more ways and develop new skills that remove bottlenecks. This ultimately reduces dependency on specialized resources and so improves agility. Next, there's architecture. Utilizing an approach of fine-grained deployment helps improve build independence and increase source code to production velocity. An API-led architecture drives value and benefit, aligning directly with the aspirations of the digital business of driving consumption of new services. Being event-driven enables real-time capture and propagation of change, critical to success of aligning systems for a single coherent view of the business. And finally is the technology piece. Adopting an integration platform that supports the right mix of traditional and modern integration styles is absolutely crucial. The technology platform should be built on a cloud-native infrastructure and should have a set of integration capabilities which are easy to use together, and also should have a set of common services which expedite the security, governance, and operations requirements. So how do we evolve over time to a more agile architecture? What we're looking at here is what we started with. This is what we call a foundational approach to integration. This is where a lot of organizations are now, and it uses an integration bus to tie together the systems of record and also to expose services via an API gateway to internal consumers. Looking at what the combination of the design approach of modern applications combined with integration looks like, we start to see a slow, steady evolution of slowly appearing modularized components. This is gradual rather than rip and replace and includes our applications in the top right and integration components lower down. We're doing this using containerization for an architectural approach, combining people and process to align teams towards an application component focus based on microservices principles, until we achieve a distinct split of ownership of integration components aligned with application components where we have achieved our initial goals of people, architecture, and technology agility. Now let's look at how IBM is supporting its customers in this kind of approach to modern integration. The IBM Cloud Pak for Integration supports a cloud-native approach to deployment by providing the underlying architecture of Red Hat OpenShift and a set of world-class, best-of-breed integration capabilities, including full lifecycle API management and security, industry-leading integration capabilities, messaging with transactional and event propagation support, and high-speed file transfer. This set of capabilities shares a single platform and interface for security, administrative management, and monitoring with the enterprise-grade pedigree you expect from IBM. Now let's look at what this looks like for a developer looking to deploy an MQ Queue Manager container under the Cloud Pak for Integration. In this demonstration, we will be using a Red Hat OpenShift Container Platform instance to deploy an MQ Queue Manager microservice. We will be drawing the resources from GitHub for a source-to-image build. We are using a Jenkins pipeline to automate this build and deployment. The Jenkins pipeline will combine the image build and an invocation of the MQ operator to deploy a customized Queue Manager image in a container. For this demonstration, we're going to start in the IBM Cloud Pak for Integration user interface. We're on the home page. We can see a list of runtimes here. We have a gateway capability and a Kafka cluster. In our runtime, in our capabilities, we have an API Connect API management instance, an App Connect dashboard, and some utility services as well. So because this is a source to image build and deployment into the Cloud Pak runtime, we're going to start with our GitHub repository for the Queue Manager that we're going to deploy. Let's start and look at the Docker file. We're going to take the IBM entitled container image from the IBM entitled registry and add a layer to that image, which will be a copy of the MQSC file in this repository into the actual image itself, so the queue manager can be configured with the behavior that is required. Let's take a look at that MQSC file. It provides us with channels and queues that we need defined for the purposes of the demonstration, and also some authentication configurations to allow us access to the queue manager. We're also going to create a build configuration which will build the image from the Docker file in the repository. Here's our OpenShift build config. We're taking the source from the Git URL that we're currently in and creating an image from the entitled registry and creating an image string object with a tag of MQIBT latest. From that build, we're going to actually deploy that image. We're going to create a first class object in OpenShift called a queue manager, so based upon the use of the operator, the queue manager operator. And we're going to use the image that we've just built and some configuration parameters along with that. We'll have a single instance queue manager named QM1. So let's go to our Jenkins pipeline now. So we have a two-step process, an MQ build and an MQ deploy. Let's have a look at our MQ build step. This is a script-based build, and we're going to use the repository we were just looking at and execute a script. We're using the OpenShift OC command because we're running in a pod in OpenShift. We could easily do this in a standalone environment as well. So we're going to create the build configuration, and we're going to create a key and a route for use with the queue manager, and we're going to then start the build of the queue manager itself. The MQ deploy step, let's have a quick look at that. Again, our source code management configured for the Git URL. The deployment is a very simple step. We delete any queue manager object which currently exists, and then we apply the MQ deployment YAML to create the queue manager object. So let's run the build. We'll start that build, and let's have a look at the output of that. We can see our objects have been created, and we're just going to wait until that build finishes. Right, that build's finished. We can see it's triggered an MQ deployment. Let's have a look at the build output of that. And then we can see that our queue manager MQ1 has been created after applying the deployment.yaml file. So back to our IBM Cloud Pak for Integration home page. Let's just update the list of the runtimes here. I can see QM1 on the list here is ready to go. And so I'm going to just click on the link, which is going to open up an MQ Queue Manager console. Here's my Queue Manager console. Now what I can do is simply drill down and manage my Queue Manager QM1, and we can see here we have the queues as defined by the MQSC file, and now as a developer I can go ahead and test my Queue Manager. So that concludes the demonstration today. What we've seen is a source to image build of an operator-based deployment of an MQ Queue Manager using a GitHub repository for our artifacts and a Jenkins pipeline for the build and deployment.